We are on section 7.1 of our textbook. Let's do some of the sample problems here. Let's look at this first one. It says, we know that 5 squared is 25, so 5 is the square root of 25. And 5 cubed is 125, so the cube 5 is the cube root of 125. 5 to the 4th is 625, so 5 is the 4th root of 625. By definition then, in our book, on the middle of page 363, it says, for any positive number, a to the nth equals b, then the nth root of b is a. These two are inverse functions of each other. Now, let's look at the first one. I'm on page 364. So the first one they give us is 0.008. Now you could press that on your calculator. Cube root. So I'm going to do shift. I got to get back to calculator mode. Shift cube root of 0.008, and it says that's 1/5, which is 0.2. So if we took the cube root of 0.008, that is 0.2 times 0.2 times 0.2, and so the cube root is 0.2. Negative 1,000 cube root. So on our calculator, we could press the cube root of negative 1,000 is negative 10, because negative 10 times negative 10 times negative 10 is negative 1,000. Last one is 1/27th, so we could press the cube root of fraction 1/27 is 1/3, so the cube root of 1/27 is 1/3 times 1/3 times 1/3, which is 1/3. Okay. In a square root, I'm on the middle of the page, this number here is called the index. This number here is called the radicand. And this number here is the radical sign. So, I'm on page 364. The cube root of negative 27. Well, negative 27 is negative 3 times negative 3 times negative 3. So the cube root of that, you got 3 3's here, is negative 3. All right, page 365. I'm trying to illustrate this with playing cards. So let's look at the first one here. I gotta get these in order here. First one first. Okay. So here we have a picture that tries to illustrate for you the square root of 4. No. This is not the one that I was doing. 4x to the 6th. I thought for some reason I thought it was 2. That's why I chose the 2 here. Oh, wait, I know why. Because 4 is 2 times 2. So the first thing you want to do is find the prime factorization of this number 4. So if I do that, if I press 4 and then I do the prime factorization, factors, you see it right here, factors. So I press shift, factors, it says 2 squared. So this is 2 squared x to the 6th, and we're doing the square root. So I show that you got a pair of 2's and you got 6 jacks. I'll say j to the 6th rather than x. There is no x card on your in the playing cards. But the rule that we're going to use is the rule for Go Fish, which you can lay down pairs, because this radical or this index is a 2. So we're going to group them by 2's. We got 2 here, 2 here, 2 here, 2 here. And so when we get done, we can lay them down, and we would have 2x to the 6th is 2, and then a pair of jacks, another pair of jacks, and another pair of jacks, or 2x to the 3rd. A pair of 2's and 3 pairs of jacks, or 3 pairs of x's. Let's look at the next one. Notice on the next one, they changed the rule on us. Now it says we have now it says we have the cube root. So the rule changes. We're going to lay them down by 3's. A to the 3rd, A is our queens, and B to the 6th, so we got 6 kings here. 3 queens, 6 kings. So when we lay them down now, we have to lay them down in groups of 3. So the cube root of A cubed k to the 6th is cube root, so we're going to lay them down by groups of 3, is of, oops, it wasn't, I was going to put q there. They have A to the 3rd, B to the 6th. So we have one group of A's and 2 groups of B's. So the cube root of A to the 3rd, B to the 6th is one group of A's and 2 groups of B's. There's one more example that they have. Just wait here. And that is, we lay them down by groups of 4. So let's look at an example here. We have groups of 4. So here we go. fourth root of x to the fourth y to the eighth. If you lay them down in groups of 4, notice in groups of 4, you end up with that as your answer. So you should be able to do page, just wait here. On page 366, you should be able to do 1 through 54 and be able to do them on the board. You won't, I don't want you to hand in your paper, but be able to do all of those. Let's not go to 54. Let's go to 51. 51. Okay, that's what you got to do.